Alright, in this video I'm going to present a fun experiment that's going to look at thermal diffusivity effects in conduction. So I've got a mug of hot water, a metal knife and a plastic knife. I got 2 ice cubes. I just heated the water up in the microwave for about 3 minutes. So before we get into doing this, I'm going to talk a little bit about what thermal diffusivity is and why it's important to think about. So thermal diffusivity, I'm going to display the equation here, is the thermal conductivity divided by the density and the specific heat. It's sort of a combination of properties that's important for transient conduction, which is what we're going to do here. And transient in the sense that the action of moving the knife onto the ice cube is going to be sort of a short time frame. And in that time frame, the important parameter is thermal diffusivity. And it's important to consider this because thermal diffusivity is often mixed up with thermal conductivity, where right now we're concerned with how fast heat is moving between the objects, which is thermal diffusivity. And then here on this side, I want to display the heat diffusion equation. So we have the spatial variation in temperature, which we're not really concerned about right now. Possible heat generation, we don't have any. And then here on this end, over here, is the temperature variation with time. And you see that thermal diffusivity is a coefficient of that parameter. And that's really what we're focused on here, is how fast is heat going to move between these objects and the ice cubes. So I've done some research, and I've found that the thermal diffusivity of stainless steel, which is close to what I have here in my butter knife, is about 4.2 millimeters squared per second. And that's how, if you think of like the area, it's going to move over that area in 1 second. Whereas plastic, this knife, has a thermal diffusivity of 0.096 millimeters squared per second. That's a lot less than metal. So what we can expect is when I try to move my plastic knife through the ice cube, it's going to go a lot slower. Also, we can expect the metal knife to move quick and melt a good groove in the ice cube. So now as we do this, since it's conduction, they're going to be touching, we have to think about how quick the heat from the knife moves through the water. And that means the knife is going to get cold. So that's one thing we're going to test where we're going to touch it with our fingers and see if it gets cold. Now, the one thing I really like about this experiment is that it's really easy to do. Anyone can do it. And that's why I think it's going to be fun to present to kids, because you have just some hot knives and we're going to cut through ice. Now, the hotter the knives get, the more careful you have to be, but the more quickly they'll cut through the ice and the more fun it can be. So right now I've just heated up the water in the microwave. It's not going to be super quick or super amazing, but it's going to be interesting to do. So let's give this a shot. We're going to start with the plastic. It's been heating in the water. And we're going to give it about 30 seconds to move through the ice. I'm going to go back and forth a little bit here, create just a little friction, make it a little more interesting. As you can see, I'm not making a whole lot of progress. The plastic is not really moving through the ice. It's just sort of staying put. Pretty boring. And as I touch the plastic, temperature's not changed real much. It's still about room temperature. If I can pick the ice up, we can see there's not really a groove in this ice cube. It's just pretty much the same. Maybe I can. Nothing's really happened. All right, let's try the metal knife now. Get this a little closer. So you can see the steam coming off the knife. I'm going to use the non-serrated end. And look, it's just sliding down the ice cube there. Give it about 30 seconds. And you can see I've already made a decent groove, so much faster than the plastic knife. There's a huge difference here, which is just fascinating in my opinion. So it's been about 30 seconds. If you can see there's a nice groove in my ice cube. I've put a lot through it. Now if I had a really hot knife, I could almost just cut that ice cube in half. Just perfect down the middle. I've kept it sort of cooler now, just heating up water in the microwave. This is something you can do. I can touch the knife. It's cold now. I can put my finger in the water. I'm not burning myself, which makes it real. Sort of family-friendly, kid-friendly. No one's going to get hurt. It's just a fun experiment to do to sort of see how different materials and their different thermal diffusivity affect conduction. Thanks for watching.